Hello everyone, welcome to Sunya IAS, and this video is the part of your ongoing series of HYT for the subject of Science and Technology. And in this video we are going to cover the topic of nuclear fusion. Alright, we already covered in the previous video the concept of nuclear fission, where I gave you a bit of a hint that what this concept of nuclear fusion is and how it is different from nuclear fission. In this video we are going to talk in detail about this topic, because I again feel that this topic is important for this year's preliminary examination, because we have two big news aligned up which are responsible for a potential question from this topic. The first news is that China's east, that is China's artificial sun, in that they have able to sustain this nuclear fusion or this UHT of plasma, right, for about 1056 seconds. When we talk about 1056 seconds, आपको लग रहा होगा seconds and नहीं, it's a huge landmark deal with respect to the process of nuclear fusion. इतने time तक fusion sustain करना is a very much complex deal. Second news we have lined up with respect to this topic is the Jet Laboratories UK has also able to sustain it for 5 to 6 seconds, but they have yielded electricity out of it, which is our whole purpose of establishing the nuclear fusion based nuclear reactors. All right, so let's quickly begin. But before we begin, I have an announcement to make that if you want to complete your entire science and technology syllabus for this year's UPSC preliminary examination, so we have video lectures as a crash course for you guys, where you can complete the entire syllabus in just 25 hours, right? And this you can also supplement along with the static notes which we give you, and together they both complement each other and can become your one-stop solution for the subject of science and technology. All right, so let's quickly begin with this nuclear fusion. So सबसे पहले, like we understood in the nuclear fission, let's first understood and create a mental block that what nuclear fusion is. ठीक है जी. सबसे पहले I assume that you all must have studied either in school or while your preparation in the subject of geography that sun में एक procedure is there which is responsible to give all the energy which is coming out of the sun. That process is your fusion. ठीक है. Ideally sun में क्या हो रहा है सर? Sun में there was this hydrogen which is getting fused into helium, and while hydrogen is fusing into helium, there is a release of energy which we can even feel on the surface of Earth, which is about 1 astronomical unit away. ठीक है sir? So do remember, and what happens is, and also once this entire helium hydrogen gets fused into helium, then the death of the star starts, or the star death starts, which is also in the technical word calls as stellar nucleosynthesis. All right, तो ये process चल रहा है sir. Now हमने सोचा, or the scientists thought that this process which is going on inside the sun, if it is able to give this much amount of energy that we can even feel from million of kilometers away, why can't we have the similar process on the surface of the earth and generate electricity from this? ठीक है, तो that when we are replicating the process which is happening in the sun on the surface of the earth, we replicate into a laboratory or a mechanism or a structure that is called as your what? Plasma reactors or tokamak reactors. ठीक है. So nuclear fusion में हो naturally कहाँ पे रहा है? In the stars, and in stars it is also in the uncontrolled format. Earth पे if we want uncontrolled format, so it is hydrogen bomb. Similarly, if we have uncontrolled fission on Earth, that will be atom bombs. तो ये भी एक difference याद रखना है. ठीक है. Do remember, uncontrolled fusion will lead to hydrogen bomb. Uncontrolled fission will lead to atom bomb. Clear? Then uncontrolled fusion, if we talk about naturally, it is found in stars. If we have to have it in the controlled format on the surface of Earth, then we have plasma or tokamak reactors. Clear? Now we are moving on to understand that what we are doing in the process of fusion, and then we will see the mechanism which was in use, your tokamak reactor or China's artificial sun, that what is happening about it. ठीक है, चलो. Then if we talk about, हमने last class में sir ये देखा था, there are fusion means that two basically atomic nuclei will be colliding with each other. But you know that since, let's say there is a neutron and there is a neutron, they have a same charge, how they will bind with each other. ठीक है. सेम तो रिपेल करते हैं ना सर. मैग्नेट में आपने सुना नॉर्थ पोल रिपेल करेगा. जिसको ज्यादा टेक्निकल नॉलेज नहीं पता, मैग्नेट से समझो सेम पोल तो रिपेल करेगा. तो जो दो चीजें विच आर इन सेम नेचर, दे विल बी रिपेलिंग ईच अदर. नाउ द चैलेंज इज दैट हाउ टू फ्यूज देम, because when they fuse with each other, there is a release of energy जो सन में आ रही है. सन में भी क्या हो रहा है? hydrogen is getting fused into helium, and from that fusion we are getting energy. पर वो energy आती कहां से? Again there is a concept behind it. What happens is basically, let's take helium. ठीक है. तो हमने एक चीज पिछले लेक्चर से याद रखना, whenever we are talking about fusion, तो यहाँ पे हमेशा two lighter nuclei will be attaching with each other, and fission में there were heavier elements, we were going away from each other. ठीक है. Now helium, let's take helium. Helium has basically 2 protons and 2 neutrons. ठीक है. When these 2 protons and 2 neutrons attach with each other, there is an energy that when they bind, they release some energy, and that energy is called as your binding energy. ठीक है. When they bind with each other, there is a binding energy associated. That energy now where we are going to harness. Fission में क्या था? When uranium 235 was breaking away, there was the release of energy along with the release of neutrons, जहां से chain reaction चलता था. पर यहाँ पे क्या है? कुछ भी नहीं. Protons and neutrons are binding with each other. When they bind or they collide with each other, there is a release of energy. ठीक है. And that energy is called as binding energy. And ये energy we have to harness from the process of nuclear fusion. But understand one thing, sir. Now we have helium. Helium cannot be the fuel. Let's take hydrogen. पर hydrogen का atomic number is 1. There is nothing that there are no two things which are going to bind with each other, and simultaneously there is no release of binding energy. And अगर binding energy नहीं होगी, from where what we'll harness? We will have nothing to harness. Then what is the solution that we found? We thought that okay, ठीक है, hydrogen में अगर एक ही है तो let's take its isotope. That is deuterium. ठीक है, don't confuse deuterium oxide, ठीक है, D2O, that was heavy water which was used as a coolant or a moderator in that reactor. वो ठंडा करने के लिए था. यहाँ पे it is acting as a fuel itself. ठीक है सर. चलो, so its isotope that is deuterium. तो deuterium में क्या होता है? 1 proton and 1 neutron. We'll take one deuterium. We'll take one deuterium. One deuterium has 1 proton and 1 neutron. One deuterium has 1 proton and 1 neutron. When they will bind with each other, what they will lead to? Helium, because helium has 2 proton and 2 neutrons. Deuterium 1 proton 1 neutron, 1 proton 1 neutron. Helium 2 proton and 2 neutron. And when they will bind with each other, what will happen? They will do subsequent release of energy. ठीक है. And then we can take another isotope, that is tritium. Tritium में what will happen? There will be 3 to attach with each other. There will be more release of binding energy. तो ये एनर्जी हमको हार्नेस करनी है. पर सर अब चैलेंज हमारे पास ये है कि let's compare it with मैग्नेट कि यार मैग्नेट के 2 पोल्स तो आपस में रिपेल करते हैं. हाउ वी आर गोइंग टू ज्वाइन देम? फिर हमने सोचा कि यार इफ दे आर एबल टू ज्वाइन विद ईच अदर, है ना, इन द स्टार्स, तो व्हाट इज हैपनिंग इन द स्टार्स? तो हमने सोचा यार स्टार्स में ना ये प्रोसेस होता है. पहले समझो स्टार्स में प्रोसेस क्या होता है. स्टार्स एक बड़ा सारा नेबुला होता है. बेसिकली इट्स अ बिग क्लाउड और बिग नेबुला. व्हाट हैपेंस? इट कीप्स ऑन गोइंग बिगर, बट व्हेन इट ग्रोज सो मच बिगर, देन कम्स द रोल ऑफ ग्रेविटी व्हिच कंप्रेसेस इट. ठीक है, तो बड़ा होता जाता है. देन व्हेन इट गेट टू बिग, तो ग्रेविटी कम्स इनटू प्ले एंड इट कंप्रेसेस इट. व्हाइल ग्रेविटी कंप्रेसेस इट, तो कंप्रेशन की वजह से देयर इज एसोसिएटेड प्रेशर. कंप्रेशन की वजह से एसोसिएटेड प्रेशर बढ़ जाता है. विद द इंक्रीज ऑफ प्रेशर देयर इज अ इंक्रीज ऑफ टेम्परेचर, एंड देयर इज सो मच सो इंक्रीज इन टेम्परेचर दैट हाइड्रोजन स्टार्ट्स फ्यूजिंग. तो सेम भी फ्यूज होने लग जाते हैं बिकॉज ऑफ द प्रेशर एंड एसोसिएटेड इंक्रीज इन टेम्परेचर. Now we had a problem. We thought that how we are able to create that pressure. So sun is like so much bigger than the earth. It will have so much gravity that will be compressing it, and the associated or the related pressure would be there. But how will be able to bring that on earth? How will be able to bring that on laboratory, which is like even smaller than the earth, which is smaller than the sun? तो हमने सोचा we cannot bring that pressure. So what we do? So we cannot generate the pressure, but their pressure alone was not responsible. In the sun, pressure की वजह से there was this associated increase in temperature. So let's leave pressure. Let's directly reach on the temperature. Can we reach that temperature? So the answer was yes. And this increased temperature is there inside the nuclear fusion reactor, which is then responsible for fusing these two. But वहां पे negative क्यों है? Then why are we worrying about the seconds? ठीक है, अगर इंक्रीज टेम्परेचर है तो रखेंगे. बट जस्ट इमेजिन अगर सन के हम पास जाएंगे, द सैटेलाइट्स विल मेल्ट. हाउ कैन यू सस्टेन अ टेम्परेचर, ठीक है, दैट इज इवन मोर हॉटर देन द सन्स कोर ऑन द surface of अर्थ इनसाइड द लेबोरेटरी. So when I say that jet laboratory was able to sustain it for 5 to 6 seconds, that means the temperature reached. But अगर उससे भी ज्यादा it was not able to sustain, because अगर उससे ज्यादा होता the entire the facility would have melted away. ठीक है, तो that was what I mean. Then it is a huge deal to for sustain it for 1056 seconds. Now let us look what is happening. So artificially, naturally stars में होता है, the concept associated is pressure associated temperature. ठीक है, but यहाँ पे pressure है ही नहीं. तो we found a solution. That solution is sir temperature. But फिर question आया, sir इतना temperature how will be able to like sustain this much temperature, or how will be able to generate this much temperature? So the answer was by electricity. in a vacuum chamber, वहां पे we'll make a plasma. ठीक है, but then the problem was there was so see let me move to the next slide and explain you how it is done. So basically what happens is this, see this is basically a toroidal structure. तो टोकोमैक इसको रशियन लैंग्वेज में बोलते हैं. बेसिकली दिस स्ट्रक्चर इज अ टोरोइडल स्ट्रक्चर. यहाँ पे सारे इसमें मैग्नेट्स हैं. दिस आई एम टेलिंग यू हाउ वी हैव मेड दिस. ठीक है, तो यहाँ पे मैग्नेट्स हैं सारे, एंड इन मैग्नेट्स के बीच में वी आर रनिंग इलेक्ट्रिसिटी एंड देन वी आर एडिंग अ फ्यूल in the form of hydrogen or deuterium. तो ये जो आपको प्लाज्मा दिख रहा है ना, earlier it was in the, so basically what happened, we had a fuel that was your deuterium. Deuterium को हमने ऐड किया, but the temperature was so high that deuterium started acting in a plasma form. So what is plasma? Plasma is an ionized gas. तो उतने ज्यादा टेम्परेचर पे when we are putting inside deuterium, it becomes plasma, and plasma में temperature becomes so high that the deuterium fuses with each other, giving rise to helium, and we have energy. But we have a problem, sir. What will happen is that this plasma has a characteristic that when this is in a ionized form or in a plasma form, if it touches anything, ठीक है, this plasma will lose its ability, it will just melt away. ठीक है, तो जो अपना आयोनाइज्ड गैस होने की वजह से वो फ्यूज करवा रहा है ना, if it touches anything, it is going to lose its property. तो हमने सोचा यार अभी ऐसा क्या करें that inside a structure where there is a vacuum, the plasma should be rotating but it should not be touching anything. तो हमने बोला what we can do is what we will bring this magnets, but these magnets we will make these magnets to act as superconductors. Let me sum up अगर समझ नहीं आ रहा. ठीक है, हमने टेम्परेचर ज्यादा रिलीज करना था. ठीक है, टेम्परेचर ज्यादा लेके आना है. क्यों? क्योंकि द फ्यूल विच इज ड्यूटेरियम, सो दैट इट शुड फ्यूज विद ईच अदर. बट फ्यूज किस स्टेट में करेगा? प्लाज्मा स्टेट में. बट प्लाज्मा स्टेट हैज वन मोर कैरेक्टरिस्टिक और वन मोर चैलेंज फॉर अस गाइस, दैट इफ प्लाज्मा टचेस एनीथिंग ना, तो अपना टेम्परेचर सर लूज कर देगा. इट विल नॉट बी एबल टू फ्यूज सम थिंग्स. सो फॉर दैट वी आर नाउ फाइंडिंग अ सोल्यूशन. ठीक है, लेट्स कम बैक. So problem was plasma loves isolation. ऐसे याद रख लेना. ठीक है, now what we do that plasma is not touching those magnets, not touching those those super magnets, है ना. So हमने क्या करा, उन magnets में we inculcated a property that is called as superconductivity. Now what is superconductivity? Just understand. Let's say this is your normal wire and wire के बीच में no current is being passed. ठीक है, तो there will be free moving electrons. यहाँ पे घूम रहा होगा, यहाँ पे घूम रहा होगा, यहाँ पे. Movement we pass electricity through a wire, any normal wire I'm talking about, there is no special wire. ठीक है, जो आपका भी you will be studying on your study table, आपके लैम्प के साथ associated wire है. ठीक है, all these wires, इसमें current pass हो रहा है. When we pass current, all these electrons start moving in the same direction. ठीक है, but when they move in the same direction, what happens is they hit each other also. आगे बढ़ते बढ़ते एक दूसरे के मार रहे हैं पीछे. ठीक है, then what happens is then there is a subsequent resistance. तो एक दूसरे के बीच में हिट करेंगे, सो देयर इज अ सब्सिक्वेंट रेजिस्टेंस. ठीक है, विच इज देयर, एंड दैट रेजिस्टेंस की वजह से देयर इज अ लॉस ऑफ एनर्जी. जाना तो आइडली आगे चाहिए था सेम डायरेक्शन में, बट देयर हिटिंग ईच अदर, देयर इज अ लॉस ऑफ एनर्जी. बट देयर इज अ लॉस ऑफ एनर्जी. आपको कैसे ये पता चलेगा? बिकॉज इफ यू आर यूजिंग योर वायर फॉर कंटिन्यूअसली 10 to 15 मिनट्स, वो वायर हीट हो जाएगा. दैट हीट एनर्जी इज कमिंग आउटसाइड, बट दैट इज ऑफ नो यूज टू यू. So that means you are having a loss of energy. So that is a loss of energy. So what can be the process? ठीक है, so the process is that if we cool or if we are putting this wire into a super cooled temperature, then it will be reaching a stage of superconductivity and there will be no loss of energy. ठीक है, अगर इस वायर को हम बिल्कुल कूल टेम्परेचर्स के ऊपर जाके -273 पे जाके वी आर गोइंग टू पुट दिस वायर, देन देयर विल बी नो रिलीज ऑफ नो लॉस ऑफ एनर्जी. दैट इज योर स्टेट ऑफ सुपर कंडक्टिविटी. इस सुपर कंडक्टिविटी से हमारे एक साइंटिस्ट थे जिनका नाम था माइसनर. ठीक है, माइसनर इफेक्ट. सुपर कंडक्टिविटी की प्रॉपर्टी से वी डिराइव्ड माइसनर इफेक्ट. व्हाट डज माइसनर हैज टू से? ही सेज दैट लेट्स से दिस इज अ मैग्नेट, इट इज नॉर्थ पोल, इट इज साउथ पोल, एंड दिस इज अ मैग्नेटिक फील्ड ऑफ अ मैग्नेट. ठीक है, subsequent field will be on this side also. He said, now let me place two objects. Earlier there was this wire which was not in a superconducting mode. ठीक है, it was a normal wire. So magnetic field will pass through this. Magnetic field will pass through this. But on the other hand, I am placing an object which has a property of superconductor. So what he observed that this magnetic field was not able to cross through the superconductor and it was repelling it. The moment it is repelling this, it will push the magnet away also. Similar property will be used in those magnets also. ठीक है, so हमने क्या करा सर, इन वाले मैग्नेट्स को सुपर कंडक्टिविटी की प्रॉपर्टी दिलवा दी. कैसे? सो इनको हमने आउटसाइड पे फ्रॉम दिस आउटसाइड लेवल वी कूल्ड देम विद हीलियम. And you will be amazed to know that these are the magnets in the world which have a highest temperature gradient. Under देखो, there is a plasma, the temperature which is even more hotter than the earth, sun's core, and then here they are super cooled to maintain the this property of superconductivity, and with the Meissner effect they will repel the what? They will be repelling the plasma. So this is how plasma is able to sustain, and so and there we have this toroidal structure in which the plasma runs, and this temperature reaches to a point which is even hotter than the sun's core. That's why we are not able to sustain them. Okay, Jet Laboratory was the one which was able to sustain it for 5 to 6 seconds only. Then came the China. It was not basically able to sustain the same model as of Jet Laboratories, which is not important for your UPSC examination also. It was this is called as UHT. Okay, so it was able to release UHT for 1056 seconds, and that's also a huge deal. So do remember this. ठीक है, understood? This is the process. तो हमने क्या करना है, टेम्परेचर ज्यादा, we will increase the temperature to such an extent that the two जो repulsion की force है between the same poles, जैसे magnet वाले same between the same atomic subatomic particles, right? We have to eliminate it. How will we eliminate it? By increasing temperature to such a level that they fuse with each other. ठीक है जी. So the fuel for here would be deuterium. ठीक है, deuterium will be fusing into helium. All right. चलो. So this was the entire thing. Please remember all these concepts. Then nuclear fusion, this we discussed. So two light nuclei are going to combine with each other. Deuterium is going to two deuterium will combine into helium, again two lighter. Then mostly deuterium and tritium are used. Third, energy produced is more than that or in nuclear fission. Just imagine nuclear fission हम करवा रहे हैं, उससे ज़्यादा energy produce होगी. The energy is there in the core of the sun. ठीक है, so do remember from this example that nuclear fusion has more energy than that of nuclear fission. Then there is no long-lived radioactive waste produced. उसमें we saw 3 stages. At subsequent stage we had a production of a nuclear radioactive fuel. ठीक है, इसमें नहीं है. If deuterium is getting converted into helium, helium is also there in the air. There is no even if the entire deuterium gets fused into helium, there will be no leftover fuel that will be nuclear radioactive. ठीक है, नहीं होगा कुछ भी. Then there is no chain reaction as it was there, and यहाँ पे plasma cools if disturbed. पर हमें क्या चाहिए, disturbed मतलब if it touches anything, he loves isolation, and cool हो जाएगा तो our whole purpose will be defeated. There will be no increase in the temperature and subsequent joining of these deuterium atoms. ठीक है, चलो. Then if we talk about what are the experiments we are performing with respect to it, number 1 we have ITR, that is International Thermonuclear Experimental Reactor. कहाँ पे है? It is in Cadarache, France. Remember this. Then ITR version of India. So basically what is ITR? ITR is a collaboration of around 35 countries. Every country has its own tokamak reactor where they are contributing to the overall large project which is getting run in Cadarache, France. ठीक है. So basically when it began, basically there was 5 to 6 members. Then India joined in the year 2005 and it became 7th member, and now we have 35 members. Okay. Then it is in India, if we have this reactor, it is called as Aditya Tokamak. So jo bhi you see any mission in the UPSC examination which is named as Aditya, so it will be always related to sun. Just we have Aditya Tokamak, that means sun. ठीक है, it is Aditya means sun. So sun का जो process replicate कर रहा है that tokamak. Aditya L1 mission that is there to probe the sun. ठीक है जी. So then it was built indigenously in 1989, located at Gandhinagar, Gujarat में है, याद रखना. Which is the department associated, again Department of Economic Energy would be there. ठीक है, which will be controlling this. Then total members are 35. I already told you, याद कर लेना. Then do remember this thing that IAEA, ठीक है, is also a member of ITER. International Atomic Energy Association, है ना? So headquartered in Vienna, is also a member of this. Then we are on China's east, so it is Experimental Advanced Superconducting Tokamak. अभी सारे शब्द आपको समझ लग गए होंगे. Experimental level पे Advanced Superconducting Tokamak. ठीक है जी. Tokamak is basically toroidal structure. Russian में इसको Tokamak बोलते हैं. चलो. It is also called as artificial sun. So UHT stands for ultra high temperature. It has been able to sustain ultra high temperatures, long pulse plasma discharge of 102 seconds, and now it has shifted to 1056 seconds. Another landmark discovery. Clear, sir? To remember. Then we have Jet Lab UK. So इन्होंने क्या करा? They have also been able to sustain this reaction for just 5 to 6 seconds, but that 5 to 6 seconds matter a lot, because in this 5 to 6 seconds they were even able to extract electricity out of it. That is around 59 megajoules of energy. Clear? And that's a huge deal. Then please do remember, if we talk about the difference, one barrel, the energy produced from 1 barrel of fossil fuels can be given by a half glass of water ठीक है, क्योंकि इसमें हाइड्रोजन के आइसोटोप्स यूज हो रहे हैं, तो हाफ ग्लास ऑफ वाटर में से जितने ड्यूटेरियम निकलेगा उतनी एनर्जी इज गिवन टू अस नाउ अ डेज बाय 1 barrel of oil. So this is the benefit of this. So let's read few benefits, and that will be the last slide. So positive is higher electricity generation than nuclear fission. Clear, sir? It will be a clean energy, no radioactive waste would be produced. Then sustainable source of energy, because hydrogen is never going to finish, है ना? जैसे uranium deposits and they'll end one day. Thorium है, thorium will though abundant, it will end one day. But hydrogen थोड़ी end होगा यार, ठीक है? Then economical and cost effective also. There is no need, like हमने 7 stages करे थे, इसमें कुछ नहीं, we just need 1 laboratory and then we need a glass of water or deuterium, and then we can add and run the reaction. And there is no proliferation risk also. This is very important, because the moment you hear the word that in the process there is something nuclear, and in the exam let's say there is a question with respect to proliferation, you will say that something nuclear and no proliferation. No, this is not possible. नहीं sir, इसमें there is no proliferation. किसकी proliferation कराओगे? Proliferation was there in the concept of nuclear fission, because fission में if we enrich uranium 235 है ना to the highest extent, enrichment मतलब that is your concentration, increasing the concentration. If we increase the concentration to 200%, that will become your weapon grade uranium that we studied there. ठीक है, weapon grade uranium. And the same uranium, when it was enriched only on 20%, was being used as a reactor grade, which was our fuel. So there is a risk of proliferation. ठीक है, इसीलिए जब वो अपना जो JCPOA हुआ था with respect to Iran, USA had this one clear demand that Iran, you should close or shut down not your nuclear reactors but your nuclear enrichment plants. दिस इज व्हाट दे मेंट बाय दैट. अभी ये भी न्यूज समझ में आ गया होगा, ठीक है. सो एनरिचमेंट में क्या हो रहा है, सेम यूरेनियम विच इज एक्सट्रैक्टेड फ्रॉम नेचर इज फर्स्ट एनरिच्ड, or means that it is its concentration is increased to be used in the nuclear reactors, and if we increase their concentration to a highest extent, then they can even be used as a weapon grade. ठीक है, but similar thing, deuterium को जितना भी ज़्यादा आप enrich कर लो, कुछ भी कर लो, nothing can be created as a weapon grade. Clear sir? So do remember this, but only if it go like uncontrolled version, है ना, so that can become a hydrogen bomb. Clear sir? So no proliferation risks also, so do remember. And that was it with respect to nuclear fusion. If you feel any doubt with respect to it, don't hesitate to comment below, and see you guys in the other videos. All the very best. Thank you so much.